All right, you guys, Mr. Burns here with your video for lesson 4.2, writing linear equations for graphs. Your target for this lesson, what I want you to learn in this lesson is I want you to be able to write a linear equation for a given graph. So on the top of your page, it says a linear equation can be written for a specific line if you know the slope and the y-intercept. The y-intercept can be determined by locating the 0, b coordinates where the graph crosses the y-axis. The slope must be calculated using the slope triangle or the slope formula. When dealing with graphs representing real-world situation, the y-intercept represents the initial value and the slope is the rate of change. So it says writing a linear equation from a graph there in the pink box. 1. Locate the y-intercept on your graph. 2. Find the slope of the graph, of the line. And 3. Write the equation in slope-intercept form, y equals mx plus b. So again, the example there, if you need to, take a look at the example and make sure you read it, analyze it, and hopefully it'll help you. Let's take a look at the next page. It says it is very useful to have equations for graphs that represent real-world situations because you can use the equation to predict future or past data. When using a graph to help find values not shown on the graph, you can write a linear equation that represents the line and then use the equation to calculate for other ordered pairs on the line. So again, example number 2, okay, make sure you read through it if you're having a hard time. The one thing that they do show you on this page is this right here. In other words, they're using the slope formula to calculate the slope. All right. And once they have the slope, as long as they can figure out what the y-intercept is, I'm not the y-intercept, sorry, but the y-intercept, okay, then they can figure out the equation from there. On this page, okay, it's giving you another example. All right. It says Geraldo attended the state fair with his friends in August. There was an entry fee, plus each ride cost an additional amount. The graph shows the relationship between the amounts spent during the number of rides he went on. So it's just kind of a different situation. The one thing about this example is if you look at this one compared to the other one, there's no line that connects those dots because this is a discrete situation and it's not continuous. Okay, so here we are in your tiered worksheet. Now, if you're listening to what I'm telling you to do, at the end of this video, there's going to be a little Easter egg that is worth 10 points. 10 extra points. If you're listening to the video, you're going to earn yourself 10 points. If you're not listening to the video, guess what? You're going to lose 10 points. So hopefully you're listening to this video. Okay, your instructions for numbers 1 through 4 are: determine the slope and y-intercept for each graph. Write the equation for the graph in slope-intercept form, or y equals mx plus b. Now here's the one thing, okay, about these graphs. So up here at the very top, you might want to write this down. Choose a color, say blue, and here we go. So read graphs from left to right. This will help you to determine the proper slope and also help you to determine what the y-intercept is. Okay, so let's take a look at number 1. And I'm going to zoom in so you guys can see what I'm doing. So on number 1, the first thing we want to do is determine the slope. So choose a starting point. And what I said before, you want to read your graph from left to right. So this point. So is this a positive slope or a negative slope? So if I'm reading from left to right, am I going down the mountain or up the mountain? If I'm going down the mountain, my slope is going to be negative. That's the first thing you should determine. Now make your slope triangle, and we're going to go straight down. So count with me. 1, 2, 3, 4. So that's my rise over my run, which is 1. And actually, I messed up, didn't I? So let's fix it. So if I mess up, you might want to go back and fix what I messed up, or fix where I messed up. So it's still a negative slope. Let me erase my slope triangle. and start over. So again, from that point there on the left, so 1, 2, 3, that's my rise, and my run is 1. And then when I reduce this, my slope is -3. Now, my y-intercept is the point at which this line crosses the y-axis. So here's your x-axis. Here's your y-axis. And at what point does this line cross the y-axis? It's at -2. So that is my y-intercept, -2. So my equation in slope-intercept form is y equals my slope, which is -3, times x. And in this case, it's -2, because that's my intercept. All right, pretty easy. Number 2. All right, here we are, number 2. Move this over just a touch. Okay, so my slope. So again, reading from left. So in this case, I'm going to read from left to right. Am I going up the mountain or down the mountain? In this case, I'm going up the mountain, so my slope is going to be positive. So pick the first point. Draw a slope triangle. So I'm going to go 1 up, that's my rise, over my run, which is 1, 2, which brings me to my next point. So my slope is 1, 2. Let's check it. 1 up, and then 1, 2 to the right. Okay, cool. Now, what's my y-intercept? At what point, okay, does my line cross my y-axis? That's at -1. This point right here. So my equation is y equals my slope, which is 1/2, times x minus 1. All right, number 3. Okay, number 3, reading my graph from left. I don't know what that is. From left to right. Pick my first point right there. Make my slope triangle to this point right here. So am I going up the mountain or down the mountain? I'm going down the mountain, so my slope is negative. So I'm going to go my rise, 1, 2, so -2, over my run, 1, 2, 3, so -2/3. And then at what point does my line cross the y-axis? So here's my x-axis, there's my y-axis. Okay, so at what point? +2, right there. So my equation is y equals -2/3 x plus 2. Okay, number 4. Okay, so number 4. Looking at my graph, going from left to right. Here we go. So am I going up the mountain or down the mountain? I'm going up the mountain, so my slope is going to be positive. So going from left to right, this is the point I start off at, and I'm going to go to this point there. So I'm going to draw a slope triangle. So what's my rise? 1, 2, 3, 4, 5. That's my rise. And my run is 1, 2. So +5, 2. My y-intercept, so at what point does my line cross my y-axis? That is right here, and that's +3. So my equation is y equals 5/2 x plus 3. Okay, let's take a look at number 5 and 6. Okay, so here we are on the second page. So your instructions for 5 and 6, okay, it says determine the slope and y-intercept for each graph. Write the equation for the graph in slope-intercept form, okay, and y equals mx plus b. So here we go. Just like before, reading our graph from left to right. Let's take our first point right here. And let's see, is this a positive slope or a negative slope? Am I going up the mountain or down the mountain? When I go from left to right, I'm going up the mountain, so guess what? My slope is going to be positive. So it's going to be up 1 over 1. Okay, that's my slope. And when I reduce that, it's 1. And then my y-intercept is the point at which my line crosses my y-axis. And what is that? It's right here at -5. So my equation is y equals x minus 5. Okay, number 6. Okay, so on number 6, Looking at my graph, going from left to right. Okay, is this a positive slope or a negative slope? Well, it's a flat horizontal line. Okay, it's a flat horizontal line going from left to right. So I wonder what kind of slope that is. In this case, it's undefined. It's a zero slope. But it still has a slope, and I'll show you how you find that out. So your slope, okay, so reading from left to right, from this point to this point, what's my rise? 0. What's my run? 1, 2. And what is 0 divided by 2? That's 0. What's my y-intercept? So at what point does this line, okay, cross the y-axis? So you got your x-axis, you got your y-axis. So at what point does it cross the y-axis? That's right here at positive 3. So my equation is y equals, since I got a 0 slope, I don't have to put anything down for the slope, so it's just y equals 3, and that's it. Okay, number 7. So on number 7, it says the graph to the right represents the distance y Kelvin has walked after x seconds. What is the slope-intercept equation for the graph? So just like before, okay, going from left, so let me choose a different color here. Oh, let's see, what color should we use? Use like a different shade of blue. So reading this from left to right, is this a positive slope or a negative slope? It's a positive slope. And what's my equation? So let's see, going from left to right, where does this line start? Right here at the origin. Okay, so my slope is positive, and let's see, we're going to go Kelvin. Okay, he's got a positive slope. Okay, and then so from that point to this point, let's do our slope triangle. So 5, 10, 15, 20. And then 1, 2, 3, 4, 5. So this is first his slope. So 20 over 5 reduces down to what? 4. Okay. And then now, for his y-intercept, okay, at what point does the line cross the y-axis? That's right here at the origin. So the y-intercept is 0. So Kelvin's equation, okay, Kelvin's equation is y equals his slope 4 times x. Oops, sorry, I moved it. And then for B, it says Janice's walk can be represented by the equation y equals 6x. Who is walking at a faster pace? Okay, so who is walking at a faster pace? So you've got two equations for part B, and let's use them. So you've got Kelvin, so Kelvin's equation, okay, is y equals 4x, and Janice's equation is y equals 6x. So choose a number, whatever value you want for, for the time. So let's say, you choose 8, right? So we're going to say x equals 8 in this case. So we're going to plug 8 into the equation. So we're going to plug 8, okay, into the value for x. So Kelvin is going to go 4 times 8, which is 32. All right, so he's walking at 32. So he's walking 32 feet, okay, in 8 seconds. So let's see what Janice does. So if you got y equals 6 times 8, 6 times 8 is 48 feet. Okay, so who's walking faster, Kelvin or Janice? Janice covers 48 feet, okay, in 8 seconds, where Kelvin only covers 32 feet in 8 seconds. So who's walking faster? That would be Janice. All right. Now, here's your Easter egg. Okay, here is your Easter egg. This Easter egg is worth 10 points. Okay, so you better listen very carefully. So what I want you to do is take your packet and flip it over to the blank page. On that blank page, what I want you to do is I want you to write 5 5 friends that you have and 5 things that you like about them. So again, on the very back, on the back of your paper, on the back of your packet, I want you to write down 5 friends' names and 5 things you like about them. This is worth 10 points. We'll see who's listening to my videos or not. That's all I got. Mr. Burns, out.